This video examines published sources for educational purposes. Interpretations are attributed. No claims are asserted as fact without citation. December 7th, 1941. Pearl Harbor smolders under a crimson sky. As Admiral Yamamoto watches the smoke rise from his flagship, a crushing realization settles over him like the morning fog rolling across Tokyo Bay. The architect of Japan's most audacious military strike understands something his government refuses to acknowledge. America possesses industrial capacity so vast, so incomprehensible, that this victory will become Japan's ultimate defeat. According to historian Gordon Prange's extensive research, Yamamoto had warned his superiors before the attack that Japan could fight successfully for perhaps 6 months, maybe a year. After that, he noted grimly, America's productive capacity would overwhelm them completely. The mathematics were already written in steel and oil, in factories continent that most and foundries stretching across a Japanese leaders had never seen. Before we uncover today's secret from World War II, if you enjoy exploring the hidden stories and overlooked battles of history, please take a moment to like this video and subscribe for more untold wartime histories. And let me know in the comments where you're watching from. I'm always amazed that these memories of the past connect us across so many corners of the world. What Yamamoto understood and what his government refused to accept was that they had not attacked a nation. They had attacked an industrial colossus whose peacetime production already dwarfed their wildest military ambitions. Records from the US Bureau of Statistics indicate that by 1941, American steel production reached 75 million tons annually. Japan's entire output barely exceeded 7 million tons. The disparity wasn't close, it was catastrophic. Every American factory worker represented productive capacity that Japan simply couldn't match. Every blast furnace in Pittsburgh rivaled entire Japanese industrial complexes. The attack on Pearl Harbor wasn't just strategically questionable. According to multiple military historians, it was mathematically impossible to sustain. The numbers tell a story that Japanese planners either ignored or never fully grasped. By December 1941, American automobile manufacturers were producing 3.7 million vehicles annually. This wasn't military production. This was peacetime consumer manufacturing that could be converted to military purposes within months. Ford's River Rouge complex alone employed more workers than Japan's entire aircraft industry. General Motors production lines stretched for miles, turning out Buicks and Chevrolets with assembly line precision that Japanese military planners had studied but never truly comprehended. When these same production lines began manufacturing Sherman tanks and aircraft engines, the scale would become overwhelming for Japan's war effort. Admiral Yamamoto had witnessed American industrial capacity firsthand during his time as a naval attaché in Washington from 1926 to 1928. According to his personal correspondence, later discovered in Japanese naval archives, he had toured American steel mills, aircraft factories, and shipyards. What he saw haunted him. Single American facilities possessed productive capacity exceeding entire Japanese industries. The Bethlehem Steel Works in Pennsylvania could outproduce all of Japan's steel mills combined. Boeing's aircraft manufacturing in Seattle represented technological sophistication that Japan was still struggling to achieve. Most disturbing of all, these were civilian enterprises operating at peacetime capacity. The oil situation revealed an even more unsustainable reality. Japan's attack on Pearl Harbor was partially motivated by America's oil embargo, which had begun choking Japan's military machine. Yet records from the American Petroleum Institute show that the United States was producing 1.4 billion barrels of crude oil annually by 1941. Japan's total oil reserves, including synthetic production and captured supplies, never exceeded 60 million barrels at their peak. America wasn't just embargoing oil to Japan. America was drowning in petroleum abundance, while Japan counted every gallon. The strategic implications were staggering. Every American military operation would be fueled by seemingly unlimited petroleum resources, while Japanese forces would be constantly constrained by fuel shortages that would only worsen as the war progressed. Yamamoto's colleagues in the Japanese Naval General Staff had access to these production statistics through intelligence reports and published American data. Yet according to historian Richard Frank's research, they consistently dismissed or misinterpreted these figures. Some Japanese planners argued that American industrial statistics were propaganda designed to discourage enemies. Others believed that American society was too soft, too individualistic to sustain the collective effort required for total war. These assumptions would prove not just wrong, but catastrophically so. American society would demonstrate an organizational capacity for war production that exceeded even optimistic Japanese estimates of what was possible. The shipbuilding disparity alone should have deterred any rational Japanese war planner. In 1941, American shipyards were already producing vessels at rates that Japan couldn't match even during wartime production. The Todd shipyards in California were launching cargo ships every few months using techniques that Japanese shipbuilders were still learning. When Henry Kaiser's revolutionary shipbuilding methods began producing Liberty ships, the pace would accelerate to one ship every 42 hours at peak production. Japan's entire shipbuilding industry, working at maximum capacity, couldn't match what a single American shipyard complex would achieve during the war. The mathematical impossibility of competing with such production should have been obvious to any serious strategic planner. Aircraft production revealed perhaps the most devastating disparity. According to records from the Army Air Force's Statistical Digest, American aircraft manufacturers were producing approximately 19,400 military aircraft annually by 1941. Japan's entire aircraft industry, including both Army and Navy production, managed roughly 5,000 aircraft per year. The gap wasn't just in quantity, but in quality and technological sophistication. American aircraft like the P-51 Mustang and B-17 Flying Fortress represented engineering achievements that Japan was years away from matching. When American production shifted to wartime priorities, the disparity would become so extreme that Japan would be fighting with obsolete aircraft against enemies equipped with the most advanced aviation technology in the world. The human resources equation told an equally sobering story. America's population in 1941 exceeded 130 million people, with millions of skilled industrial workers already employed in manufacturing. Japan's population was roughly 70 million, with a much smaller percentage engaged in modern industrial production. American workers were operating in factories equipped with the most advanced machinery available, supported by vast transportation networks and abundant raw materials. Japanese workers, despite their dedication and skill, were working with older equipment, limited resources, and supply lines that would be constantly under attack. The productivity differential per worker would only increase as the war progressed and American industry fully mobilized. Perhaps most critically, American production was geographically dispersed across a continent protected by two vast oceans. Japanese planners could attack Pearl Harbor, but they couldn't reach the steel mills of Pittsburgh, the aircraft factories of Seattle, or the shipyards of San Francisco. American industrial capacity was essentially invulnerable to Japanese attack, while Japan's more concentrated industrial base would be increasingly vulnerable to American bombing campaigns. This geographic reality meant that American production would not only exceed Japanese capacity, but would remain secure while Japanese facilities came under constant threat. The research and development disparity compounded every other advantage. American universities and corporations were investing heavily in military technology development. The Massachusetts Institute of Technology, the California Institute of Technology, and dozens of other institutions were conducting research that would produce radar systems, advanced engines, and eventually nuclear weapons. Japan's research efforts, while impressive for their size, operated with a fraction of the resources and personnel available to American programs. The technological gap would widen throughout the war as American innovation accelerated while Japanese development struggled with resource constraints. Military historians like John Keegan have noted that Yamamoto's strategic assessment was remarkably accurate. Japan might achieve tactical victories for a limited period, but the underlying production mathematics made long-term success impossible. Every ship Japan sank would be replaced by multiple American vessels. Every aircraft Japan destroyed would be succeeded by superior American planes produced in greater numbers. Every Japanese pilot lost represented irreplaceable experience, while American training programs would produce thousands of new aviators with access to the most advanced aircraft and equipment. The war's outcome wasn't determined by courage or tactics, but by industrial capacity that Japan simply couldn't match. According to declassified Japanese planning documents discovered after the war, some staff officers understood these realities, but were overruled by political considerations and wishful thinking. The concept of Yamato Damashi, or Japanese spirit, was believed by many to compensate for material disadvantages. This spiritual superiority was supposed to overcome American industrial advantages through superior fighting spirit and tactical excellence. Such beliefs reflected a fundamental misunderstanding of modern warfare's industrial requirements. Courage and skill mattered, but they couldn't overcome production disparities measured in orders of magnitude. The attack on Pearl Harbor represented Japan's acknowledgement that they couldn't compete with American production in a prolonged conflict. Their only hope was a swift, decisive blow that would force American negotiation before industrial mobilization could occur. Yet this strategy required perfect execution and American psychological collapse, neither of which materialized. Instead, Pearl Harbor galvanized American resolve while providing the political justification for total industrial mobilization. Japan had awakened not just a sleeping giant, but an industrial colossus whose productive capacity would soon operate at levels that defied Japanese comprehension. As Admiral Yamamoto surveyed the burning American fleet, he was witnessing not victory, but the beginning of Japan's inevitable defeat. The attack had been tactically successful, but strategically catastrophic. Every burning American ship would be replaced by multiple superior vessels. Every destroyed aircraft would be succeeded by advanced planes produced in overwhelming numbers. The mathematics of American industrial dominance were about to transform from potential threat to crushing reality. Japan had 6 months, perhaps a year, before American production would make continued resistance futile. The countdown to inevitable defeat had begun with the first bomb dropped on Pearl Harbor. The transformation began at 12:01 a.m. Eastern Standard Time on December 8, 1941. According to industrial historian Arthur Herman's research, within hours of President Roosevelt's declaration of war, American factories that had been producing consumer goods for decades began receiving urgent government contracts for military equipment. The Studebaker Corporation, which had manufactured family sedans that morning, was retooling assembly lines for military trucks by evening. Chrysler's Detroit plants, famous for luxury automobiles, started converting production machinery for tank manufacturing. The speed of this industrial pivot represented organizational capacity that Japanese intelligence had never witnessed in any modern nation. Records from the War Production Board indicate that American automobile manufacturers alone possessed machine tools worth over $2.8 billion in 1941 currency. These weren't specialized military facilities, but civilian factories equipped with precision machinery that could be rapidly converted to weapons production. The Ford Motor Company's Willow Run plant would become the most dramatic example of this transformation. Built specifically for B-24 Liberator bomber production, this single facility would eventually produce one complete aircraft every 63 minutes at peak operation. Japanese planners had calculated that American aircraft production might double during wartime. They never anticipated it would increase by factors of 10 or more. The aluminum industry revealed another critical miscalculation in Japanese strategic thinking. According to records from the Aluminum Company of America, US aluminum production in 1941 reached 276,000 tons annually. Japan's entire aluminum output barely exceeded 16,000 tons. This disparity would prove devastating because aluminum was essential for aircraft construction, and air power would dominate the Pacific War. When the US government prioritized aluminum production for military purposes, output would eventually exceed 920,000 tons annually. Japan would fight the entire war with aluminum resources that America produced in less than 3 weeks at peak capacity. The rubber situation demonstrated how American industrial innovation could overcome apparent vulnerabilities. Japan's conquest of Southeast Asian rubber plantations was supposed to cripple American war production, since natural rubber was essential for tires, gaskets, and countless military applications. Yet according to chemical industry records, American companies had been developing synthetic rubber production throughout the 1930s. When natural rubber supplies were cut off, the United States constructed synthetic rubber plants capable of producing 836,000 tons annually by 1944. Japan had eliminated American access to natural rubber, only to discover that American chemistry could create superior synthetic alternatives at industrial scales Japan couldn't imagine. The shipbuilding revolution that followed Pearl Harbor defied every assumption about industrial possibilities. Henry Kaiser's shipyard innovations, documented extensively in maritime history archives, transformed vessel construction from a craft requiring months to an industrial process measured in days. The Liberty Ship program would eventually produce 2,710 vessels using standardized components manufactured across multiple states. Each ship required approximately 250,000 parts. Yet Kaiser's methods reduced construction time from 355 days to an average of 42 days. At peak production, some vessels were completed in less than 5 days. Japan's entire merchant marine consisted of roughly 6 million tons of shipping. America would build 5,200 Liberty ships alone, totaling over 38 million tons of cargo capacity. Aircraft engine production showcased American manufacturing sophistication that Japanese industry couldn't replicate. The Pratt & Whitney R2800 double wasp engine, according to aviation historian Bill Gunston's research, required machining tolerances measured in thousandths of an inch and metallurgy that pushed the boundaries of available technology. Yet American factories were producing these complex engines in quantities that exceeded Japan's total aircraft production. The Wright Cyclone factory in Cincinnati could manufacture more aircraft engines monthly than Japan produced complete aircraft. The precision manufacturing required for such engines demonstrated industrial capabilities that Japan had never developed at scale. The electronics and radar development programs represented technological advantages that would compound throughout the conflict. According to records from the Massachusetts Institute of Technology's Radiation Laboratory, American radar research involved over 3,900 scientists and engineers working with unlimited funding and the most advanced equipment available. Japanese radar development, while competent, operated with perhaps 200 researchers and limited resources. The cavity magnetron, developed through British-American cooperation, gave Allied forces radar capabilities that Japan never matched during the entire war. American industrial capacity could not only produce superior technology, but manufacture it in quantities that equipped entire fleets and air forces. The training infrastructure for military personnel revealed another dimension of American organizational capacity. According to Army Air Forces records, the United States established 96 pilot training facilities capable of graduating 100,000 aircrew annually by 1944. These weren't simple flight schools, but comprehensive programs that included instrument training, gunnery practice, formation flying, and combat tactics. Japan's pilot training programs, constrained by fuel shortages and limited aircraft, could never approach such scale. American pilots would enter combat with 200 to 300 hours of flight training, while Japanese pilots increasingly flew with minimal preparation due to resource constraints. The logistics networks supporting American military operations demonstrated peacetime infrastructure advantages that became overwhelming during wartime mobilization. According to transportation historian George Hilton's research, American railroads in 1941 operated 429,883 miles of track, with sophisticated scheduling and cargo management systems. The Pennsylvania Railroad alone could move more freight than Japan's entire rail network. When military production accelerated, these transportation systems could deliver raw materials to factories and finished products to ports with efficiency that Japanese logistics never achieved. The Interstate Commerce Commission reported that American railroads moved over 737 billion ton-miles of freight in 1943, supporting industrial production that dwarfed anything Japan attempted. Medical and scientific research capabilities provided American forces with advantages that extended far beyond industrial production. According to medical historian Albert Cowdery's documentation, American pharmaceutical companies were producing sulfur drugs, blood plasma, and other medical supplies at scales that could support millions of military personnel. The development of penicillin through American industrial fermentation processes gave US forces medical capabilities that saved thousands of lives and returned wounded personnel to combat much faster than Japanese medical systems could achieve. Japanese forces would fight the entire war without access to antibiotics that American forces considered standard medical supplies. The financial resources supporting American war production revealed economic capacity that made Japanese resistance mathematically futile. According to Treasury Department records, the United States would spend over $304 billion on World War II, equivalent to roughly $4.1 trillion in modern currency. Japan's entire national budget at the war's peak never exceeded $8.5 billion annually. American war spending exceeded Japan's total economic output by factors that made sustained resistance impossible. The United States could afford to build weapons faster than Japan could destroy them, replace losses more quickly than Japan could inflict them, and maintain production levels that Japan couldn't disrupt through military action. The agricultural foundations supporting American war production demonstrated resource advantages that Japanese planners had never fully appreciated. According to Department of Agriculture statistics, American farms in 1941 produced 1.1 billion bushels of wheat, 2.6 billion bushels of corn, and agricultural surpluses that could feed not only the American military, but Allied forces worldwide. Japanese agriculture, operating on limited arable land with increasing labor shortages, could barely feed Japan's civilian population. American farmers were using mechanical equipment that increased productivity per worker to levels that Japan couldn't match with intensive manual labor. The agricultural abundance would allow America to fight a global war while maintaining civilian nutrition standards that exceeded Japanese military rations. The psychological and organizational factors supporting American war production represented cultural advantages that Japanese leaders had consistently underestimated. According to sociologist Samuel Stauffer's wartime research, American workers responded to the Pearl Harbor attack with industrial mobilization efforts that exceeded government expectations. Factory workers volunteered for extended shifts, accepted rationing without significant protest, and maintained production quality under pressure that would have strained any industrial system. The democratic culture that Japanese propaganda had portrayed as weak and individualistic proved capable of collective effort that surpassed authoritarian systems in both efficiency and sustainability. Research and development programs initiated after Pearl Harbor would produce technological advantages that Japan couldn't counter through tactical superiority or fighting spirit. According to science historian Daniel Kevlar's documentation, the Manhattan Project alone employed over 130,000 people and consumed resources equivalent to building 2,000 B-29 bombers. The proximity fuse program, radar development, jet engine research, and computer projects represented scientific mobilization on scales that Japan had never attempted. These programs would produce weapons and systems that would make Japanese resistance increasingly futile, regardless of tactical skill or strategic planning. The industrial mobilization following Pearl Harbor transformed American society in ways that Japanese intelligence had never anticipated. According to historian John Morton Blum's research, American industrial production increased by 96% between 1939 and 1944, while Japan's production peaked in 1942 and declined thereafter due to resource constraints and bombing damage. The United States was not just outproducing Japan, but accelerating production while Japanese capacity diminished. By 1944, American factories were producing military equipment at rates that exceeded the combined output of all Axis nations. The mathematical impossibility of Japanese victory was becoming undeniable, even to the most optimistic planners in Tokyo. As Admiral Yamamoto had predicted, Japan's early tactical successes were being overwhelmed by American industrial capacity that operated beyond Japanese comprehension. The 6 months to 1 year of potential Japanese advantage were passing quickly, and the awakened American industrial giant was demonstrating productive power that would soon make continued Japanese resistance not just difficult, but mathematically impossible. The countdown to inevitable defeat was accelerating with every Liberty ship launched, every aircraft engine produced, and every ton of steel rolled in American mills that Japan could never reach or destroy. The steel mills of Gary, Indiana never slept. By March 1942, according to records from the American Iron and Steel Institute, these foundries were producing 2,100 tons of steel daily, running 3 shifts around the clock. Workers who had once manufactured refrigerators and washing machines now forged armor plating for Sherman tanks. The transformation wasn't gradual, it was instantaneous and total. Japanese intelligence officers, operating from consulates in neutral countries, filed reports describing American industrial activity that their superiors in Tokyo dismissed as impossible exaggeration. How could a nation simultaneously increase steel production, aircraft manufacturing and shipbuilding while maintaining civilian consumption levels that exceeded Japanese military standards? The answer lay in productive capacity that Japanese planners had never encountered in their own experience. According to historian William O'Neill's research, American machine tool production in 1942 exceeded the total manufacturing capacity of Japan's entire industrial base. These weren't weapons. These were the machines that made the weapons. Every precision lathe, every hydraulic press, every automated assembly system represented manufacturing capability that could be multiplied across thousands of facilities. Japanese industry, constrained by limited machine tool production, could never scale to match American expansion rates that seemed to violate economic laws. The workforce mobilization revealed organizational dynamics that challenged Japanese assumptions about democratic societies. Records from the War Manpower Commission indicate that American industrial employment increased from 32 million to 54 million workers between 1940 and 1945. These weren't conscripted laborers, but volunteers responding to economic incentives and patriotic appeals. Women entered factories in unprecedented numbers, operating complex machinery that Japanese propaganda claimed required masculine strength and discipline. Yet these civilian workers achieved productivity rates that exceeded Japanese military production facilities, operating under strict hierarchical control. Rosie the Riveter became more than propaganda. According to labor historian Ruth Milkman's documentation, women comprised 36% of the American workforce by 1945, operating precision equipment in aircraft factories, shipyards, and munitions plants. The Boeing plant in Seattle employed 47,000 workers by 1944, including 20,000 women who assembled B-17 and B-29 bombers with quality control standards that Japanese industry struggled to maintain with experienced craftsmen. American democratic culture, which Japanese leaders had characterized as chaotic and undisciplined, was demonstrating collective organization that surpassed authoritarian industrial systems. The logistics revolution supporting this production expansion defied Japanese comprehension of what civilian infrastructure could accomplish during wartime. According to transportation records analyzed by historian Mark Reuter, American railroads moved 737 billion ton-miles of freight in 1943, compared to 379 billion in 1939. This wasn't just increased traffic, but systematic reorganization of continental transportation networks. The Pennsylvania Railroad's main line between New York and Chicago carried more freight tonnage than Japan's entire rail system. Single American freight trains transported more raw materials than Japanese convoys could move across the Pacific under ideal conditions. The trucking industry revealed another dimension of American logistical superiority that Japanese planners had never encountered. Records from the American Trucking Association show that commercial truck registration increased from 4.5 million to 8.9 million vehicles between 1940 and 1945. These weren't military vehicles, but civilian trucks supporting industrial production and distribution networks. Japanese military logistics depended heavily on captured equipment and improvised transportation systems. American industry operated with purpose-built commercial vehicles that maintained supply chains across continental distances while supporting military operations worldwide. Scientific research programs initiated after Pearl Harbor produced technological advantages that Japanese intelligence could identify but never replicate. According to physicist James Finney Baxter's wartime documentation, the Office of Scientific Research and Development coordinated over 6,000 research projects involving 30,000 scientists and engineers. The Proximity Fuse program alone employed 1,100 researchers, working with unlimited funding and priority access to materials. Japanese research efforts, while scientifically competent, operated with perhaps 200 scientists and limited resources allocated to military technology development. The radar development program demonstrated how American industrial capacity could transform scientific discoveries into operational advantages. According to records from the MIT Radiation Laboratory, American radar research produced in quantities that equipped not just major units. Japanese radar development, constrained by limited 150 different radar systems during the war, manufacture warships and aircraft, but individual tanks and artillery quantities sufficient to equip more than a fraction of their electronics manufacturing capacity never produced systems in forces. American industrial capacity could mass-produce sophisticated electronics that Japanese factories built individually by hand. Communication systems supporting American military operations revealed infrastructure advantages that Japanese forces never possessed. According to Signal Corps records documented by historian Rebecca Robbins-Rains, American military communications employed over 15 million miles of telephone and telegraph wire by 1945. The Bell Telephone System's manufacturing capacity could produce more communications equipment monthly than Japan manufactured during the entire war. American forces operated with radio networks, telephone systems, and signal equipment that maintained coordination across global distances, while Japanese communications relied increasingly on captured equipment and improvised solutions. The petroleum industry, supporting American war efforts, demonstrated resource abundance that made Japanese fuel conservation measures appear tragically inadequate. According to records from the American Petroleum Institute, US oil refineries processed 1.8 billion barrels of crude oil in 1943, producing aviation gasoline, diesel fuel, and lubricants in quantities that exceeded total Axis petroleum consumption. Japanese forces counted fuel by the gallon, while American operations measured consumption in millions of barrels. The disparity wasn't just quantitative, but qualitative, as American refineries produced 100-octane aviation fuel that gave Allied aircraft performance advantages Japanese engines couldn't match. Synthetic materials production revealed how American chemistry could overcome resource limitations that constrained Axis war efforts. According to chemical industry records, American companies produced 836,000 tons of synthetic rubber in 1944, replacing natural rubber supplies that Japanese conquests had supposedly denied to Allied forces. The synthetic rubber plants constructed in less than 2 years capabilities that Japan had never developed. American represented industrial chemistry innovation was transforming apparent resource vulnerabilities into technological advantages that Japanese forces couldn't counter through tactical superiority or strategic planning. The aircraft industry expansion following Pearl Harbor achieved production rates that Japanese intelligence reports described as impossible, but which American factory records confirm daily. According to Army Air Force's documentation, American aircraft production increased from 19,400 planes in 1941 to 96,300 in 1944. The Consolidated Aircraft Plant in San Diego was completing B-24 Liberator bombers every 100 minutes at peak production. Japanese aircraft manufacturing, operating at maximum capacity, produced 28,000 military aircraft during their peak year of 1944 than Japan produced. American factories were building more aircraft monthly, annually. Quality control in American aircraft production maintained standards that Japanese industry couldn't match even with handcrafted manufacturing methods. According to aviation historian Bill Gunston's research, American aircraft engines underwent testing procedures that required 150 hours of operation before acceptance, while Japanese engines were often installed in aircraft with minimal testing due to production pressures. The Pratt & Whitney R2800 engine, manufactured in quantities exceeding 125,000 units, maintained reliability standards that Japanese radial engines never achieved, despite careful individual attention from skilled craftsmen. Training programs for American industrial workers produced skill levels that challenged Japanese assumptions about the relationship between experience and productivity. According to War Production Board records, American defense plants trained 1.6 million new workers in 1942 alone, using systematic instruction methods that transformed civilians into precision manufacturers within weeks. Japanese industry relied heavily on traditional apprenticeship systems that required years to develop comparable skills. American training efficiency meant that inexperienced workers could achieve productivity rates that Japanese craftsmen had developed through decades of practice. The shipbuilding revolution exemplified American industrial capacity operating beyond Japanese comprehension. Henry Kaiser's Richmond Shipyard No. 2 achieved the record construction time of 4 days, 15 hours, and 29 minutes for a complete Liberty ship in November 1942. According to maritime historian L.A. Sawyer's documentation, this single shipyard produced 490 vessels during the war, more than Japan's entire merchant 1941 and 1945 shipbuilding industry completed between. American shipyards were launching vessels faster than Japanese submarines could sink them, making the naval blockade strategy mathematically futile. Precision manufacturing capabilities supporting American war production revealed technological sophistication that Japanese industry had never achieved at scale. According to machine tool industry records, American factories could machine engine components to tolerances measured in 10,000ths of an inch, using automated equipment that maintained consistency across millions of parts. Japanese precision manufacturing relied heavily on skilled craftsmen working with hand tools and measuring devices. The productivity differential per worker was increasing as American automation advanced, while Japanese production remained dependent on increasingly scarce skilled labor. Medical supply production demonstrated how American pharmaceutical industry could support exceeded Japanese military medical care. According to medical historian Albert Cow, global military operations while maintaining civilian health standards that Dre's research, American pharmaceutical companies produced 2.3 million units of blood plasma, 1.4 billion 230 billion units of penicillin during the doses of sulfur drugs, and without access to antibiotics, that American Me War. Japanese forces fought the entire conflict Dix considered standard treatment for minor infections. The medical advantage extended far beyond immediate treatment to include surgical equipment, hospital supplies, and preventive medicines that kept American forces combat effective under conditions that would have incapacitated Japanese units. Electronic equipment production revealed American manufacturing capacity in precision instruments that Japanese industry couldn't replicate. According to electronics industry records, American factories produced over 6 million radio receivers, 58,000 radar sets, and countless electronic components during the war years. The Western Electric Company alone manufactured more electronic equipment than Japan's entire electronics industry. American forces operated with radio communications, radar detection, and electronic navigation systems that Japanese forces encountered but never possessed in comparable quantities or quality. Research and development expenditures supporting American war production exceeded Japan's entire national budget for military purposes. According to science historian Daniel Kevels's documentation, the United States invested over $3 billion in research and development programs during the war, producing technological advances in metallurgy, chemistry, electronics, and nuclear physics. The Manhattan Project consumed resources equivalent to Japan's entire aircraft production program, while representing only one of dozens of major research initiatives. Japanese research efforts, while scientifically competent, operated with funding levels that couldn't support the experimental programs that American industry considered routine investment in technological advancement. The mathematical impossibility of Japanese victory was becoming undeniable by 1943. According to production statistics compiled by historian Richard Overy, American war production exceeded the combined output of all Axis nations by margins that increased monthly. The United States was producing weapons faster than Japan could deploy them, replacing losses more quickly than Japanese forces could inflict them, and developing technological advantages that Japanese industry couldn't counter through traditional manufacturing methods. The countdown to inevitable defeat was accelerating as American industrial capacity demonstrated productive power that operated beyond anything Japanese planners had imagined possible. Quality control systems in American manufacturing maintained standards that Japanese handcrafted production couldn't match, despite individual attention to each item. According to industrial engineering records, American factories employed statistical process control methods that detected defects before they affected production quality, while Japanese manufacturing relied on final inspection methods that identified problems only after resources had been invested in defective products. The efficiency advantages compounded as American production scaled to levels that Japanese quality control systems couldn't manage, even with unlimited skilled labor. The transformation of American society for war production was approaching the crescendo that Admiral Yamamoto had predicted would make Japanese resistance futile. Every factory converted to military production, every worker trained in precision manufacturing, every technological advance achieved through systematic research was contributing to productive capacity that would soon overwhelm Japanese forces through sheer mathematical superiority. The industrial awakening following Pearl Harbor was demonstrating that American democracy could organize collective effort more effectively than Japanese authoritarianism, produce weapons more efficiently than Japanese craftsmanship, and innovate more rapidly than Japanese technical tradition. The 6 months of potential Japanese advantage were ending, and the full weight of American industrial power was about to be unleashed upon forces that had awakened a productive colossus whose capabilities exceeded anything in human history. The transformation wasn't merely industrial. It was psychological warfare conducted through overwhelming abundance. By autumn 1943, according to War Department correspondence analyzed by military historian John Ellis, American forces were discarding equipment that Japanese units would have considered irreplaceable treasures. Damaged aircraft engines were scrapped rather than repaired. Worn vehicle tires were replaced while still functional. Food rations past their peak freshness were destroyed in quantities that exceeded Japanese military supplies for entire divisions. This casual waste demonstrated productive capacity so vast that conservation itself became unnecessary. a concept that Japanese logistics officers found incomprehensible. The mathematics of industrial capacity favored America so completely that Japanese tactical victories became strategically meaningless. According to naval historian Samuel Eliot Morrison's documentation, every Japanese aircraft carrier sunk represented years of construction time and irreplaceable skilled labor. When the USS Essex-class carriers began entering service in 1943, American shipyards were launching fleet carriers faster than Japan could train pilots to oppose them. The Yorktown, sunk at Midway, was replaced by a new carrier bearing the same name within 18 months. Japan lost 4 fleet carriers at Midway that could never be replaced at equivalent capability levels. Pilot training programs revealed the sustainability crisis facing Japanese aviation. According to historian Saburo Sakai's research, Japanese pilot training had been reduced from 700 flight hours to 150 hours by 1944 due to fuel shortages and aircraft availability. American pilot training programs, meanwhile, were graduating aviators with 400 flight hours of preparation, flying the most advanced aircraft available and supported by unlimited fuel supplies. Each experienced Japanese pilot lost represented irreplaceable expertise, while American training facilities could replace losses with better prepared aviators equipped with superior aircraft. Admiral Yamamoto's prophecy had become devastating reality. By 1944, the mathematical impossibility of Japanese victory was undeniable. American factories were producing weapons at rates that exceeded Japan's ability to destroy them, training pilots faster than Japanese forces could eliminate them, and developing technology that Japanese industry could never match. The 6 months of potential advantage had expired, consumed by an industrial awakening that transformed American productive capacity into the most formidable war machine in human history. Pearl Harbor hadn't crippled American naval power. It had unleashed an economic colossus whose abundance would ultimately prove more decisive than any tactical brilliance or fighting spirit Japan could summon.